Hello, this is Romeo Cat Computers, and all the parts from eBay for the Commodore machines have finally arrived. And this is all of the things that I've got. So let's go over a few of the items that I have purchased. First, we have these capacitors, and if you remember, one of the two VIC-20s had a very leaky and crusty capacitor. I ordered a lot of 2 and I ended up with 4, so I guess the more the merrier. Anyway, I'm only going to be needing 1 for this repair, but I'll have more for the future. And in order to desolder the old capacitors, I finally got some desolder braid or desolder wick, however you want to call it. And I'll show a demonstration of how this stuff works later. And I also blew a fuse on one of the Commodores, so I got some fuses. And here I have 5 of them, so this will also provide a surplus. Right here are replacement PLA chips. Unlike the VIC chip, the PLA chips have been reverse engineered. And so this style with these 2 chips on the PCB can be had from various sellers on various sites, you know, with different colors and things like that, for about $14 to $15 a piece. So PLA chips are fairly easy to replace. In fact, these are actually cheaper than if I were to buy original PLA chips on eBay. So I'll show these working later, and hopefully they should work pretty well. And finally, I got a cartridge for Commodore 64s. This is actually a double-sided cartridge. On one side, we have the diagnostic software, which I can plug into a partially or mostly working Commodore, and it should be able to test all of the components. And then on this side, if the Commodore is not powering up or booting, it's a dead test cartridge. And I haven't read the manual, so I don't know exactly how it dead tests, but it should give me some sort of flash on the screen or something to give me an indication as to what a problem might be. So as I said earlier, the VIC video chips aren't very easy to come by, and they haven't really been reverse engineered. And that presents a problem. Now, you can get these on eBay. Specifically, I need the 3560 for the VIC-20 and the 3567 for the Commodore 64. And they can be had on eBay, but there's usually not a whole lot of them at any given time. And I've seen that the particular kinds I need can go upwards of $60, $70, or $80 a chip, which is way out of the realm of the budget of this project. So unfortunately, I'm not going to be able to fully fix all 6 Commodores at once. As for the VIC-20s, one of them's going to be fine. The other one I'm just going to have to hold on to until I can get another VIC chip. And of the 4 Commodore 64s, I think I'm only going to get 2, maybe 3 fully functioning ones, and another one is just going to become a donor board. But nonetheless, I should be able to repair most of these Commodores with all of the new parts. Anyway, I'm going to be doing the machines in reverse order to what I did last time, and I'm going to be starting with the 2 VIC-20s. So as a refresher, these are both first generation. They are of the kind that have the 2-prong AC plug rather than the more modern DIN connector. And this one's so old it's even got the monochrome style badge. That one has the rainbow badge. Anyway, both of these are capable of fully functioning, but the problem is that I only have 1 working video chip between the 2, so I can only have 1 working at a time. And as I stated earlier, that's not really anything I can fix right now. However, the problem that I will be fixing today is in the older of the 2 machines, and that's this capacitor. Now, it doesn't prevent the machine from working, but it's greasy, it's leaking, it's all corroded there. So I'm going to be replacing it with the same value. And it'll go in right there. Now that I've taken the board out, there's one major hurdle I have to overcome in order to get to the capacitor. You put a shield on the bottom. And it's not a matter of just unscrewing it. There's little points all around the board, all the way around the perimeter, that I have to desolder. And this showed up on a lot of the 64s and VIC-20s. Some board revisions didn't have this, some did, but it comes up a lot. And I actually had to desolder the shield off the bottom of a 64 in the last video, but I didn't show that. So here I am in my bathroom, which is where I do my soldering stuff because I have a nice window and fan combination to get some ventilation. Anyway, I've taken the shielding off, and these two parts right here are where the capacitor is. So this soldering braid, basically what it is it's braided copper, but it's got flux on it. And so what you do is you place this on top of thing you want to desolder, and then you put the soldering iron on top of that. It heats the solder up under here, and then the copper and flux entices the now molten solder to go onto it rather than on the board, and so then you can basically suck it up and then cut off the remaining. And I'm going to want to kind of get these flowing. That's good. That's good, because I don't know how old these solder joints are. Well, I do. They're from 1980. Alright, now let's see how well this stuff works. Getting very hot to the touch, which makes sense because it's copper. There we go, I've got some of it. Well, now there's still just a small thin little layer left, and I'll deal with that later. So this is what the braid has done. It's basically just sucked up the solder, and it's stuck to this now rather than on the board, so I can just cut this off and move on. Anyway, once I got a majority of the solder up, there was just a tiny little bit left, so what I did was I heated up the legs and then popped the capacitor out from the other side. So I'd say that stuff is pretty effective. It works sometimes better than other times, so I've seen on YouTube, but in this case definitely helped. Anyway, you can see this side of the capacitor is actually looking pretty nice, but this right here, yeah, that's not good. I'm going to have to clean the board up too. Upon closer examination, it does look like the corrosion has gotten pretty deep into this one, what looks to be a power rail, which is a bit unfortunate. It seems to still be working, at least the computer works. And this is after I've cleaned it, and I seem to have neutralized and removed a lot of the corrosion. This stuff right here is particularly tough, so I'm not sure what to do about it, but I think it should be fine for now. And so there we go, the new capacitor has been installed, and I also went and put the shield back on. I didn't solder every single one of these tabs because it's annoying and not totally necessary, but I did a few of them just to hold it in. One other thing I forgot to mention that I got earlier are these little 11 by 11 millimeter heat sinks. Now the chips on the Commodores don't usually come with heat sinks. Some later board revisions did have them, but generally it wasn't 100% necessary. However, it can prolong the life, especially since they do tend to run pretty warm. And so I'll be sticking one on about every CPU, every video chip, and maybe some other chips if I have some spares. And here we go, we have a perfectly in order VIC-20. So this is Commodore 64, number 1,968,960. And upon looking at my spreadsheet, I can recall that the only problem with this is that it has a bad PLA chip, which is where these are going to come in. So we're going to see how good these things work. So here's what one of these things looks like. It's a little PCB. It's got some pin headers on the bottom, which will fit in the socket. And it's got two very elongated looking integrated circuits, which I'm assuming these are programmable logic chips or something like that. And because people have reverse engineered the PLA chip, they are able to program these two to essentially mimic the function. And so this should be as simple as just plugging it in. And there we go. That's the installation. But does it work? Oh, you bet it does. So this board has a bad PLA chip, and there's a simple solution to that. However, as you may recall, this board also just mysteriously didn't work. And it could have been a number of things in here. I determined the power supply area over here seemed okay, but this is where the dead test cartridges come in handy. And here I have the dead test cartridge plugged in. Let's see what happens. I think this Commodore is just really dead. Well, I did a little bit more testing and I've determined that I think this one is going to have to be the donor board. And the problem is that even if I do manage to find out what the issue is, I don't have a keyboard or a case for this. And there are modern replacements, but they're a bit expensive, and that's, again, I kind of need a donor board anyway. And so here we have Commodore 64 number 5,687,740. And if you recall, this is the one that had the blown fuse and just didn't work. There were weird power supply issues, so I got to look into this one. Well, I put the new fuse in, and I forgot that I took the bad video chip out. But guess what I now have courtesy of the donor board. Alright, let's see if the dead test has anything to say. Yeah, I don't think so. Well, I've gone through and I measured all the voltages on the regulators and all the voltages on the chips, and everything checks out fine. And I think my original problems were coming from the power supply. Now this one's fine, but the external one that I was using previously was having some trouble providing enough current to actually run everything. The voltage would like drop immediately when I actually turned the computer on. And there seem to be other issues like the fuse blew and some other things that seem to have solved themselves. And so I think we're down to maybe one of the chips is bad. But as you can see, the only two chips that are socketed are the VIC chip and the SID sound chip. Everything else is soldered in place, and that is just the most annoying thing. And since everything's soldered in place, that's going to be real problematic. So now if we look at it big picture, I only have 2 working video chips between all 4 Commodore 64s, and this is one of them. And I pulled that one off of the other donor board. And so in the end, I'm only going to be able to pick 2 Commodores to get fully working, and there's going to be 2 that are going to have to be left for the future. Now that other Commodore, the one with the cool keyboard flap thing, that one works fine, except its video chip is bad. So I think I know what I'm going to do. So I put the VIC chip back in here, and this will be a working computer. And I haven't needed to use the Diag cartridge yet, so I figured I may as well just show you what it's like. Now you can see there's a bunch of stuff that say bad here, the control port, serial port, cassette port. I'm pretty sure that's because you're supposed to plug something in that it can verify the test with, which I don't have, so I don't know. Although I did notice, one nice thing I do like about this cartridge is that it will test the sound. And because I don't really have any convenient software around that makes noise, I don't know if the SID chips work or not. Now I tested this on my good computer, and I indeed did get sound out of it, but you notice a second ago, when it was doing the sound test, there wasn't anything coming out of here. I'll turn it up a bit more. But I'm wondering if the SID chip might be bad. Yeah, see, it should be playing some sounds right now. And using the SID chip from the donor board, we have sound. Yeah, that popping is because these speakers in this television are basically tin cans. But it works, so I also sniffed out that problem. It's a good thing I had that cartridge, or else I would have just sent this back to Sioux Falls assuming that the sound was fine. And here's the results of the 2 video chips that I had. I put the good ones in here and also fixed these up fully. And these ones are for future work. So this right here, it had a bad PLA chip, so I replaced it with one of the brand new ones. This one had a bad video chip, and so I replaced it with one of the video chips from one of those computers. And over here, this computer had the weird power supply issues to begin with. I seem to have solved that, but all of the chips are unsocketed, and so I can't make a whole lot more progress right now. And this one is just totally dead. I verified all the chips that I can work, and I can't get anything out of it. So this is going to be a donor board. This one's going to kind of be a donor board. I think I could probably fix it in the future if I go through and replace all of the chips with socketed chips and then verify it that way. But that's for a whole other video. And as for the VIC-20s, I replaced the capacitor, and that's about all I had to do. Anyway, that's going to be it for this video. I may make a follow-up in the future if I do make some more progress on those 2, but I'm not guaranteeing anything anytime soon. Thanks for watching.